Okay, stop looking at the Nvidia stock price for a second.
Yeah.
Seriously, put down the charts, close the tabs on OpenAI, and let's talk about the actual reality of the situation.
Right.
We are all obsessing over the gold rush. You know, the AI revolution, ChatGPT, GPUs.
It's the classic iceberg problem. We see the tip, the software, the branding, but we completely ignore the submerged mass that actually holds it all up.
And that submerged mass is effectively a single point of failure for the entire global AI economy.
It really.
Which is exactly what we're unpacking today. We're not talking software. We're not even really talking about chips in the usual way.
No.
We're talking about the hidden Shogun of the semiconductor industry.
A company that holds a 100% market share in a technology you absolutely have to have.
And 100% is a number you almost never see.
Yeah.
So if you're an investor or you just care about how all this tech actually works,
you need to know this story, because if this one link breaks, the AI boom doesn't just slow down.
Stops. That is a massive claim.
Yeah.
And usually I'd be skeptical, but the sources are undeniable.
They really are.
So our mission is simple. Expose the fragility by looking at this one company.
Yeah.
To do that, we have to start with the physics.
Right. We have to go down to the atomic level.
Let's get into the weeds then. We know about TSMC in Taiwan.
Mm-hmm.
They're building the factories for 2-nanometer, 3-nanometer chips. The brains for Nvidia's Blackwell GPU.
Exactly. The absolute cutting edge. And to make chips that small, you have to use EUV lithography, extreme ultraviolet.
We've talked about this before. It's basically black magic.
It is. You're blasting tin droplets with a laser to create light with a wavelength of 13.5 nanometers.
Which is barely even light. It's almost an X-ray.
Precisely. And in this process, you have a critical component called the photomask.
The stencil.
The stencil, the master negative, whatever you want to call it. It has the circuit design. You shine EUV light on it. It reflects the pattern onto the silicon top.
Standard stuff.
Yeah.
But here's where the sources point out the nightmare scenario.
Right.
Because we're dealing with features that are just a few atoms wide, the mask has to be perfect.
And perfect is, well, it's a heavy word in engineering.
I can imagine.
The sources say a single nano-sized dust particle or a tiny defect in the mask material itself
Can ruin the entire pattern.
the entire pattern. And if the mask is wrong,
Every single chip you print with it is dead on arrival.
correct. And a single EUV mask set can cost hundreds of thousands of dollars.
So if you print 1,000 wafers with a bad mask,
You have burned a hole in your balance sheet the size of a small country's GDP. So obviously you have to inspect the masks first.
Which brings us to the core problem. I was reading the technical breakdown, and my first thought was, okay, just look at it.
Right.
We have powerful microscopes, lasers. Why can't we just scan the mask and find the dust?
That's the intuitive thought, but it fails because of physics.
Also,
Standard optical inspection uses light with a longer wavelength. The problem is, some of these defects are phase defects, or they're buried just under the surface.
so if you shine a normal laser at it, the light just goes right over it.
It passes right over. It's invisible. It's like trying to find a tiny scratch on a clear window pane. In some light, it looks perfect.
But when you hit it with EUV light,
Suddenly, that scratch casts a shadow.
So the defect is a stealth defect. It's invisible to inspection, but it shows up when you actually try to print the chip.
Which is a complete disaster. The only way to find a defect that reacts to EUV light is to inspect it with EUV light.
This is what the industry calls actinic inspection.
Actinic, that's the key term.
It sounds like a comic book weapon.
It just means using the same wavelength for inspection as you do for manufacturing.
Okay, and this is where the story gets really interesting. Because a decade ago, the entire industry, Intel, Samsung, the big equipment makers in California, they all knew this was the ideal solution.
They knew it, theoretically.
But they didn't build it.
They tried, but they gave up. You have to understand the engineering nightmare. Generating EUV light is hard enough for the massive ASML machines.
Right.
Trying to build a smaller, precise inspection tool that uses that same unstable, dirty light source in a vacuum, it was seen as impossible.
So the giants of Silicon Valley just said, the ROI isn't there, it's too hard.
Exactly. They bet they could use mathematical models, electron beams, basically, to guess where the defects were.
Wow.
They thought actinic was a science project that would never be commercially viable.
Which created this massive technological vacuum, a huge hole in the supply chain.
A hole that one company was about to fill.
And into that vacuum steps our hidden Shogun. Let's introduce them.
Yeah.
We're going to Yokohama in the Kanagawa Prefecture of Japan.
To a company called Lasertec Corporation.
Now, be honest, before we dug into this, you hadn't really heard of them, right?
Not in a major way, no.
They're not Sony. They're not even Tokyo Electron.
No, they are a niche player,
Yeah.
but within that niche, they are not just a competitor. They are the absolute ruler.
The source material is very explicit here. Lasertec developed the world's only machine capable of inspecting EUV masks using actinic light.
And only is the operative word. This isn't a case of having the best or fastest machine.
They have the only machine.
The only one.
Let's check the data on that. I'm looking at the market share numbers for 2024. What is Lasertec's global market share for actinic EUV mask inspection?
It's 100%.
100%. That is a staggering number. In tech, you have duopolies. Apple and Samsung, Intel and AMD.
Right.
Even ASML has some legacy competition.
But 100%. How did a company in Yokohama beat the entire world?
It comes down to a concept in Japanese manufacturing culture called monozukuri.
Craftsmanship.
It's more than that. It's a dedication to the process, to the art of making things that goes beyond quarterly reports.
The sources use this great analogy. They compare Lasertec's engineers to a master swordsmith forging a legendary blade.
I love that image.
Yeah.
Because the US companies, they operate on a quarterly cadence. If a project doesn't show ROI in 3 years, it's cut. Lasertec spent decades researching this. They were working on it when EUV was still a pipe dream. So while Silicon Valley was chasing easier wins, Lasertec was just grinding away at the physics.
They accumulated what's called tacit knowledge.
Yeah.
Stuff you can't write in a patent. It's the institutional muscle memory of how to stabilize a plasma light source.
You can't just hire a bunch of PhDs and replicate that overnight.
You can't. So when the industry finally hit a wall and realized, oh no, we actually do need actinic inspection.
Lasertec was the only one standing there with a working machine.
Exactly.
And now they hold the keys to the kingdom. Let's talk about what this monopoly really means. They're the hidden Shogun. How do they exert that control?
It's a choke point, a
Yeah.
literal bottleneck. Think about the chain. Nvidia designs the chip.
Right.
They send the design to TSMC. TSMC creates the masks. But before TSMC can put those masks into the ASML scanner,
They have to verify them.
and the only machine that can do that is made by Lasertec.
So if that machine breaks, or they can't get one,
TSMC cannot guarantee the mask is clean. If they can't do that, they can't print the chip. If they can't print the chip, Nvidia has nothing to sell.
so Jensen Huang at Nvidia cannot ship his newest AI superchips without Lasertec's stamp of approval.
That is the fundamental reality. The entire trillion-dollar AI valuation bubble rests on the optics inside a machine built in Yokohama.
Which brings us to the what-if scenario. This is the part that makes risk managers sweat.
It should.
We talk about decentralization all the time, but physically,
Physically, we are incredibly centralized. Lasertec is a real company with a real factory, and their primary R&D and production is concentrated in Yokohama.
and Japan is geographically active.
It's a seismic zone. The sources are blunt about this. What happens if there's a massive earthquake in Kanagawa? A fire? A power grid failure?
If that factory stops,
The supply of these tools stops, and the backlog for these machines is already years long.
a disruption would send a shockwave through the global economy.
It would make the 2021 chip shortage look like a minor hiccup.
It's the paradox of specialization, isn't it? The tech had to get so hard that only one company could do it.
And now we're held hostage by that success.
Let's pivot to the financials. Because the sources say Lasertec is a favorite among insider investors.
Well, of course. It's the ultimate business model.
100% market share, and your customers are desperate.
You have immense pricing power. You can basically name your price.
No price wars.
There's no one to have a war with. There is no second option for TSMC to threaten them with.
And that cash flow just feeds back into the business.
It's a flywheel. They take those massive profits and pour them right back into R&D. They're already working on the next generation of inspection while everyone else is still trying to figure out the current one.
So the gap is actually widening.
It is.
Yeah.
It makes them a very attractive, though very expensive stock.
It's interesting, the sources also touch on their sustainability goals. You don't usually see that with chip manufacturing gear.
Right, chip making is incredibly energy intensive, but it goes back to the yield rate.
The waste.
Exactly. Think about the energy, the water, the chemicals to process one silicon wafer. It's a huge carbon footprint. Now imagine you do all that and then realize the chips are all dead because the mask was dirty. You have to throw the whole wafer away.
A total waste of all that energy.
So by catching that defect before printing, Lasertec is preventing all that waste. Every time their machine finds a flaw, they save potentially thousands of wafers from being scrapped.
So this monopoly is actually a critical part of green computing.
In a weird way, yes. It connects back to that Shogun idea. They control the quality, the waste, and the speed of the whole industry.
And they're doing it from the shadows. You know, we always hear the geopolitical narrative, the US designs, Taiwan manufactures,
And the Netherlands builds the machines.
and Japan provides chemicals or something.
But this changes the map. This puts Japan in a position of incredible, quiet power. They control quality assurance. And at this scale, quality assurance is the product.
Indispensable is the perfect word.
It is. You can't remove Lasertec without breaking physics, or at least setting the industry back a decade.
So bring this back to you, the listener. Why does this matter?
It matters because it illustrates the reality of the world we've built. We think of the digital world as robust, distributed, the cloud.
Sounds like it can't be broken.
But the cloud lives in servers. Servers run on chips, and the chips are made with masks verified by one building in Yokohama.
It breaks the illusion.
It does. It's more like a global assembly line. And if the person at the quality control station gets sick,
The line stops. That is a sobering thought. We're building these massive AIs, and the ability to build the brains for them rests on the shoulders of one company.
which brings up the big question. Can the world afford to have only one Shogun?
Will governments eventually step in and say, this is a national security risk? Will we see some Manhattan project to clone this tech?
History suggests they'll try. China is certainly trying. But as we saw, trying and succeeding are very different. You can't easily buy that tacit knowledge.
For now, the Shogun reigns supreme. Okay, before we wrap, a final thought for you to chew on. We've talked about the risk of centralization, but think about this. In a world obsessed with redundancy, with decentralized AI, with blockchain, why have we allowed the physical verification of our intelligence to become so centralized?
It's the ultimate irony. We're building decentralized software on top of centralized hardware.
And is the global economy more fragile than we think because of it? If one building in Yokohama is all that stands between us and an AI crippling chip shortage, maybe we need to rethink what security really means.
It's not just about shipping routes anymore. It's about the physics of light and who controls it.
Who controls the light controls the future. A good place to leave it. This has been a deep dive into the hidden Shogun, Lasertec Corporation.
A fascinating look at the invisible architecture of our world.
We hope this gave you a new perspective on what's happening behind the scenes of the AI revolution. Thanks for listening, and we'll see you on the next deep dive.